All right. So you do need to know some things from pre-cal, though, in order to do polar functions. The first two are pretty straightforward, and that's what you learned pretty early in trig is that x is equal to r cosine theta and y is equal to r sine theta. Hopefully that's something that you're like, oh yeah, I remember that. Okay. Hopefully, within the next few minutes it'll be more than I remember seeing something like that, and it'd be something where, oh, I know that again. Okay. The other part is the area of a sector. That's going to be really important to us for developing our area formulas. So back in geometry, we used this formula for the area of a sector, m over 360 times pi r squared. The m over 360 gave you what fraction of the circle you were working with, and the pi r squared is the area of the whole circle. Remember, you guys do know, I should have, instead of just jumping in, you do know what a sector is, yes? Okay, like a pie-shaped piece. Okay, so to convert this to a radian angle, theta, remember that the degree measure is equal to theta times, the radian measure is equal to theta times 180 over pi. So if you do all that, and I'm not going to go through it all, but you end up with this really nice simple expression for area, 1/2 r squared theta. I think you used that in pre-cal last year for finding areas. It's been a long time though. Okay? It's not so much that you have to have this memorized, it's just we're going to use that to come up with something for calculus. So the slope for a polar curve drawn in the xy plane is still dy over dx. In order to get that, what you have to do is figure out what y is, take its derivative with respect to theta, then figure out what x is and take its derivative with respect to theta also, and then you end up with dy dx. So let me show you how that works out. So we want to write an equation for the line tangent to the rose curve, r equals 2 sine of 3 theta, at the point theta equals pi over 6. Just in case you're curious, you're like, rose curves. Do I remember those? Rose curve, it looks like that. Hopefully that looks at least somewhat familiar. Why are you telling me no? You didn't learn it polar?
Okay, so our class was 2 years ago, and then it's COVID.
Oh, you were in the COVID class. Oh, that's right. Yeah. At some point, you're probably going to need to pick up how to do polar stuff. I don't have time to teach you today, but
I'm going to learn it by myself.
okay. So this is what this looks like. And basically what they're asking for, this is pi over 6 right out here. They're asking for, well, what does the tangent line look like? So we're going to try and figure out what that is. So let's jump in. So first I would do, well, what is y equal to? Well, remember, y is r times what? Times sine of theta. So that's going to be 2 sine of 3 theta times sine of theta. So then dy d theta is going to be 2 sine 3 theta times cosine theta plus sine theta times I missed something.
William Cadonas.
He has a mask with the holes for the eyes are like this big.
Okay.
Looks like an idiot, but
Well,
So this will be times 6 cosine of 3 theta. Everybody good with that? And then x is equal to r cosine theta. So that'll be 2 sine 3 theta times cosine theta. So dx d theta is going to be 2 sine 3 theta times negative sine theta.
Now he has an audience.
Plus cosine theta times 6 cosine 3 theta.
It's giving Ninja Turtle.
So then our slope is dy dx evaluated at theta is equal to pi over 6. So let's see if we can do all of that. Actually, let's go ahead and find xy first. So the x coordinate is going to be 2 sine of 3 times pi over 6 times cosine at pi over 6 Let's see, that'll be 2 times sine of pi over 2. Sine at pi over 2 is 1. Cosine at pi over 6 is square root of 3 over 2. So does this whole thing end up being the square root of 3?
Yep.
Looking at Lynn. And then the y coordinate is going to be 2 sine of 3 times pi over 6 times sine at pi over 6 So again, sine at pi over 2 is 1, so that's 2 times 1/2 is 1. So we have our xy coordinates, square root of 3 comma 1. I'm going to real quick sneak a peek at our graph and see if that kind of makes sense. So out here, let's change the grid to rectangular. So at pi over 6, I've done something wrong. What else is new today? Because this is pi over 6 is the end of this deal.
What is it?
It is.
Yeah, maybe he'll know. If you put on his mask, you'll be able to think of the right answer.
Probably not. Is the x coordinate even the square root of 3? Nope.
What's going on?
I don't know.
I think we're a little lost.
Have you tried Hare Krishna?
What?
Never mind.
That was funny.
Thanks.
I didn't get it.
So please do not. So sine at pi over 2 is 1. Cosine at pi over 6 is square root of 3 over 2.
Not yet mathing today.
Yeah.
Wow.
That's just one of those days. Where's it at?
So the problem is the square root of 3, 1 would be not even on this. Square root of 3
It's like
Be like in here.
Does it
No.
change when you do polar coordinates?
No.
Oh, okay.
2 sine 3t. Yeah, that's pi over 6, pi over 3, pi over 2. Yeah. Did you find something? Well, crap. Let's see if I stole this one out of the book, and I'll just look in there. Maybe I'll get lucky on that. Polar functions. Yeah. Graph, finding area. Nope, not that. Converting, nope. Slopes, yes. It's 1 square root of 3. Did I do it backwards? No, it's square root of 3, 1.
Did you graph it?
Maybe it's a graph.
It's probably, well, it's gotta be the graph.
Pardon?
Mathematica.
Just talking about what it's wrong.
All right, well, let's just go from here and see what happens. I'm not happy about it, but there's... So let's go ahead and figure out what this is. So we already have calculated this part, didn't we? Pardon?
I graphed on my calculator. It's 1.7321.
Okay,
So
I'll see what's going on in just a second.
That's square root of 3.
yeah, the square root of 3 is 1.73.
Yeah, that's square root of 3.
Is it
Yeah.
degrees or radians? Or does that matter?
It shouldn't, no, it's doing it in radians. All right, so anyway, back to this. Notice that part of the reason I wanted to calculate this is because, notice, that's right here.
Yes.
So that's the square root of 3 plus, and then here we'll just have to figure out what this is. So that's going to be cosine at pi over 2, which is 0. So all that's going to be 0. Over here, we're going to have 2 sine, so that's 2 times a half is negative 1 plus 0 is negative square root of 3. Tell me that that's right. Yes. So the equation is y is equal to 1 minus the square root of 3 times x minus the square root of 3. That's just point slope. Wait a minute, if that's 2 sine 3t, why the heck is this out here at 8?
I don't
Hit
know.
enter. Until it goes.
Try redoing.
The length of the petals should be 2.
The settings correct?
Oh,
Oh.
what?
What?
What? Well,
Shoddy
I think it's
trifling.
fixed.
Yeah.
So now it's suddenly doing it right.
Yeah.
Yeah.
They use the
You should
same-
beat it up. You
use
should
the
throw
same-
hands with
You
your
should
Now he's
save
really
that.
gonna rage quit.
The rage quit is coming. All right. So now if I graph that line, y equals 1 minus square root of 3 times x minus the square root of 3.
Wow.
Alakazam.
Perfect.
So what I was doing was right. I don't know why I graphed it wrong.
That's why I don't trust technology.
They're on the
Yeah.
same level.
5G trying to take over your life.
5G is really
Trying to take your job.
5G
All right.
coming for
Rage
you.
quit.
Moving right along.
Mr. Benjamin Irvine, all of pre-cal last year.
That's so funny.
So now we need to talk about area.
Oh my god.
Yes? Oh, she wasn't talking to me.
So bad.
Yes.
Retweet.
So before, when we've done area, we always did it with kind of the idea of this Riemann sum. We took the area underneath, we split it up into tiny little strips which we could approximate with rectangles and added them all together. And that's what the integral did for us. The integral of the area function gave us, the integral of the height function gave us the area, right? And the integral of the area function gave us the volume, okay? When you're using polar coordinates, nothing is done this way because everything is about how many degrees it is from the positive x-axis and how far out from the origin it is. It's the radius, r, and it's theta, which is the number of degrees. So what happens instead is this is approximately a sector that we talked about a moment ago, where it was 1/2 r squared theta. So what's going to happen is that every one of these our slices, instead of being vertical, are going to be radial. They'll come from the origin outwards. Okay? Which is the whole deal with polar to begin with. You do everything radially. You do nothing rectilinearly.
What's the benefit?
There are some functions that it's a lot easier to graph in polar form than in others. And if you think about things like anything that involves a circle, like the night sky, the way things move, they don't move, in x's and y's. They sweep around. Okay, so anything that moves that way, it's a lot easier to do it in polar coordinates. So, it's a fair question. It's like, is this something that, it's not like we're doing Lobachevskian geometry where you're like, why would anyone do that? And there's probably a reason, but I don't know what it is.
Give the child that name.
Lobachevsky? That was his last name.
Maybe my child
Still.
first.
All right.
To inherit that?
Yeah.
I want
So, well, if you were in Russia, you wouldn't think anything of it. So
Fair enough, I hate Russians.
it. You deleted all the recording.
that's the most Irfan thing to say ever.
They're gonna come. No, they're gonna come for me.
Irfan's like, I hate British people. And I'm like,
The Russian spies are coming from you.
why?
Just because the Vladimir Putin actually watches Mr. Davis's
Yeah.
calculus videos for fun.
And he needs to learn calculus.
There you go.
And some taste.
So
Yeah.
remember, the area is 1/2 r squared d theta, where d theta is this little tiny change in theta. Because remember, every time you change theta, it sweeps out a little bit more. Okay, so if you want to find the area of the whole thing, let's cut to the chase. It's just the integral from alpha to beta of 1/2 r squared d theta. It even rhymes.
Do a little jig.
Alphabet beta.
Or the integral from alpha to beta of 1/2 f of theta squared d theta, which doesn't flow off the tongue nearly as nicely. So let's do an example. Find the area enclosed by the cardioid. R is equal to 2 plus 2 sine theta. Do you have to know what the cardioid looks
Is
like?
it the heart one?
Yeah, that's why it's called a cardioid.
That was where the guesswork came from, Mr. Davis.
So just real quickly, a refresher on graphing ones like this. And I think Mr. Hedstrom, because we talked about it a long time ago about, what is the best way to teach graphing these things? We worked with some people who would have people find 24 points and plot all of them and then graph it. And I'm like, I don't know, that seems like at least 6 times too many. I graphed 4 points, okay? And one of them is the same point as where I started. So when theta is equal to 0, sine of 0 is
Zero.
0. Yes, you do need to know that. So the radius is equal to 2. At pi over 2, sine is 1. So that's going to be 2 plus 2 times 1 is 4. So now my radius is 4. At pi, I'm going to be back to 2. And you may be going, well, wait a minute, you put it at negative 2. Yeah, this is pi positive 2. I've gone pi radians around, and I'm 2 units away from the origin on that. At 3 pi over 2, sine is negative 1, so we're at 0.
Ah.
So what does this look like? Kind of like this.
But
It's an upside down heart
That's kind of cute.
or a moon.
Say but.
But
When we were talking about Russia and Vladimir and someone watching these videos, I thought of that time. It was either geometry or 7th grade, but you said there was a legion of old ladies in Florida that like to hear the sound of
Yes.
your voice.
that's 7th grade.
7th grade, really?
Yeah.
I couldn't. I just remembered that.
Went
Anyways,
to the A material.
yeah,
Bring it
that was
back.
A material.
So what we can do here to find the area is simply find the area of this whole thing, all the way from 0 to 2 pi. So the area will be the integral from 0 to 2 pi of 1/2 of r squared. So that's 2 plus 2 sine theta squared d theta. Now, I will tell you that on the AP exam, I can't remember the last time they made anyone do any of these by hand. However, I am going to show you how to do this one by hand because you may have a mean professor in college who's like, you should be able to do these polars by hand. And you're like,
Is he Russian?
maybe. Maybe he's Czechoslovakian, like my differential equation professor who
He's still holding a grudge.
No, for real.
we understood him. He didn't understand a word that we said.
Maybe he watches your videos.
Maybe.
just trying to figure out how well you turned out.
So squaring this, remember that you don't just square each term. This is going to be 4 plus 8 sine theta plus 4 sine squared theta d theta.
I'm gonna mess that up.
At least you know.
Like I'm a square. I'm a square terms.
And everything is fine for taking the antiderivative except for this part. This 4 sine squared theta. Like, what the heck am I supposed to do with that? Don't know an antiderivative for sine squared. Nor do I. However, I do know that sine squared of theta is 1/2 of 1 minus cosine 2 theta.
Do we know that?
At some point, you knew something at least like that.
I triggered that.
Yeah.
Oh god.
I like
Yeah,
it.
well,
Yes?
Yeah, they were fun when I memorized them.
they're fun first.
I hate trig identities.
Yeah.
I thought they're like a nice little puzzle, but
Oh yeah, when I had the paper
When I had
next
the
to me,
cheat
that was
sheet.
fun. But when he was like, memorize them.
I said, oh,
So what we'll do
Yeah, you're a good one.
is have 1/2 of the integral from 0 to 2 pi of 4 plus 8 sine theta plus when I multiply the 4 times the half and then distribute that, this is going to be 2 minus 2 cosine 2 theta d theta. And you begin to see part of why on the AP exam they're unlikely to ask you to do this just because it takes so long. So this is going to be 1/2 of, let's go ahead and group like terms and take the antiderivative at the same time. Ooh. The 4 plus the 2 is 6, so that'll be 6 theta. Plus the antiderivative of 8 sine theta will be negative cosine theta. And here's another place where it's easy to go wrong. Minus sine 2 theta? Indeed. From 0 to 2 pi. So this will be 1/2 of 12 pi. Let's see, cosine at 2 pi is 1, so this will be minus 8. Sine at 4 pi will be 0, so that's minus 0. Minus, and be careful, this is sine and cosine. Just because I'm putting in 0 doesn't mean everything is going to be 0. Just most of the things. This will be 0. This will be, well, cosine at 0 is 1, so that'll be negative 1, so this will be minus 8, minus 0. So that's going to be 1/2 of 12 pi minus 8 plus 8. I think it's 6 pi. We'll swear to it.
Swear on.
So grab your calculator and see if you can make this, everybody. That wasn't just directed at one particular person.
Yeah, do it for us.
Go, Ian, go.
And in case you're curious,
18.84955592.
that was quick.
No.
Or did you just do
I
6
just did-
pi?
Yeah, maybe.
Maybe. Cheaters never prosper.
2 pi. Maybe. For a short time. You know. Short-term glory.
Yeah.
Yep.
Yeah.
I got.
So everybody,
Sorry,
everybody
That is what I got.
agrees?
Yeah, that's what I got.
Yeah.
Well, I got it first. I said on this.
18.84955592.
Okay,
Yeah, it says 19.
moving right along then.
You did something wrong.
No, I didn't.
So here's one that requires a little bit more thought. Find the area between the loops of r is equal to 2 cosine theta plus 1. You're like, there's more than one loop? Yep. This is a limacon with an inner loop. What?
The line is
Yeah. That's as close as I can get to the French pronunciation. It is closer than the lady I used to work with who called it a limacon, and I'm like, ah,
I think that's what we called it
That's what
last
Mr.
year.
Hedstrom called
That's
it.
what
Yeah,
Mr.
I'm pretty
Hedstrom
sure.
called it.
it's a limacon.
Mr. Hedstrom definitely said limacon. Stupid American.
Yeah, French people everywhere cringe every time that happens.
Well, French people didn't create math, we did.
Limacon.
No,
No.
they created,
America.
the reason it's named limacon is because it was created by someone who is French.
Make America great again.
That's
Maybe
all right.
it's great. Actually,
America's number one.
yeah, it's like the bald eagle.
American.
All right, so let's sketch a quick graph of this. So at 0, cosine of 0 is 1, times 2 is 2, plus 1 is 3. So this starts at 3. Cosine at pi over 2 is 0, so this is going to be 1. And then at pi, cosine is -1, so this is going to be -2 plus 1 is -1, so it's back over here. Now, what you have to realize then is that somewhere between theta is equal to pi over 2 and theta is equal to pi, this crosses through the pole so that it becomes a negative r value. So what that looks like for the top half of this is sort of like that.
In that little loopy loop killed a part of me like every time.
And then the rest of it is like that. So if we're going to find the area in between the loops, we need to know when the loop starts. Well, when is this loop going to start? Well, it starts when it hits the pole, which means r is equal to 0. So I need to know 0 is equal to 2 cosine of theta plus 1. So -1/2 is equal to cosine of theta. Where is that? And we went, it's somewhere in the second quadrant. That's nice to know. Everyone's looking at someone else.
3 pi over 4.
No.
Wow.
Anything that's a pi over 4 is going to be a square root of 2 over 2.
Yeah.
Part 3. It's one of the pies.
It's one of the pies. Thanks. We have some lovely parting gifts for you.
5 or 6.
Pardon?
No.
Pi over 6 is in the first quadrant.
4 pi over 6.
4 pi over 6 is 2 pi over 3. Why would you say 4 pi over 6?
That's all math in my head.
5 pi over 7. Jesus. I didn't even do
Sorry,
the circle now.
I'm just not awake
Whew.
I just don't know the other quadrant.
today. Like any other day, I'm just not.
It's something over 6, right?
Yeah.
That's what I said.
4 pi over 6.
4 pi over 6. So,
Yeah.
but why were you saying 4 pi over
Because
6?
I knew it was pi over 6 plus pi over 2.
You did the math,
So pi
You
over
mathed
6
it.
plus pi over 2.
How did you get that?
but you couldn't reduce.
Because pi over 6 is the one that's like this.
Oh, and then he added pi over 2.
Yeah, that makes sense.
That makes sense.
The one that's like what?
What's wrong with this?
Wait. And the that's how the unit circle works in my head. It's
So Mr. Headstrom right now, that's Mr. Davis's reaction.
Man.
He's on fire.
I still have to draw out
He
the
is
unit circle.
rolling.
I'm not gonna-
He's not dead.
All right. So this happens at 2 pi over 3. So how are we going to find the area in between them? Well, when we did the area between two curves, when we were doing them with Riemann sums, we were taking the upper one minus the lower one, right? The upper curve minus the lower curve. Well, we're going to do the same thing here, except we're going to take the outer curve minus the inner curve. Okay, so the outer curve from 0 until we get to here would be everything inside of this part. It'd be everything inside of that. And then we're going to subtract off the part that's inside of this inner loop. Now, the simplest way to do this is not to you could do it this way. Let me go ahead and show you. You could go, okay, I know this needs to go all the way around to 2 pi. So what I could do is this. I could do the integral from 0 to 2 pi over 3 of 1/2 of 2 cosine theta plus 1 squared d theta. That would get me that far. Then I start doing the inner loop. So minus the integral from 2 pi over 3. And to save myself from having my head explode, I'll just tell you that that is until 4 pi over 3 of 1/2 of 2 cosine theta plus 1 squared d theta. So that's the whole inner loop, but that was only half of the outer loop, right? You're like, oh gosh. Well, wasn't this half of the outer loop? Couldn't I just multiply that times 2?
Yeah.
And if you wanted to, especially if you're like, is it 4 pi over 3? Is it? You could have actually done this. So these 2 and the 1/2 are going to cancel. So it's 0 to 2 pi over 3 of 2 cosine theta plus 1 quantity squared d theta minus, I could have just gone from 2 pi over 3 to pi. Multiply that times 2 so that the 1/2 goes away, and it's 2 cosine theta plus 1 squared d theta. Again, that's not something that I would, on this test, it's all going to be calculator. So you're welcome to chuff that into your calculator and,
Why is it integral for second one?
I'm sorry.
Why is the integral for the second one from 2 pi?
So from 2 pi over 3 to pi would be this part right here. That's half the inner loop. So from 0, right here, to 2 pi over 3 is that part. From 2 pi over 3 to pi is this part. Okay? Everybody good with that? Okay. Pardon? You're going to chuff it into your calculator and get an answer. I have no idea what it is.
1.049.
Really? Okay.
I typed it in all right.
So let's try one more. Find the area of the region that lies inside the circle r equals 1 and outside the cardioid r equals 1 minus cosine theta. Okay, again, draw a quick sketch. R equals 1 is just a circle with a radius of 1. 1 minus cosine theta is a cardioid. It's going to start at 0. At pi over 2, it's 1. At pi, it's 2. And then it's back to 1. So it looks something like this. So we want the part inside the circle, but outside the cardioid. So what we're looking at is this. So what I would do would be this. I kind of think about it in terms of quadrants when it's a figure like this. Now, a lot of times on the AP exam, they give you these crazy ones and you can't do this very well. But most of the ones in the book, you kind of can. You're like, okay, all the area I want is right here in this first quadrant, right? Well, the top half.
Yeah.
Sorry, I'm going to double everything. I should have said that
Half
first.
the area.
Yeah. So if I do the first quadrant, this is going to give me half of it. So that's 1/4 of a circle, right? So I'm going to have 2 times 1/4 of pi times 1 squared. Minus the part that's inside the cardioid that I'm not getting to shade in. So minus 1/2 of the integral from 0 to pi over 2 of 1 minus cosine theta d theta, but then I'm going to multiply that times 2 because I need the bottom one also. You're going to use the symmetry of these a lot, and so a lot of times you're going to cancel the 2 and the 1/2. Let me just say, when you have one where you don't forget that you need the half. So I write it down every single time. And then if I double it, I go, okay, great, I'm going to cancel that. But if you get in the habit of just, oh yeah, I'm going to double it at some point and not writing it, you'll forget it sometime when you're not able to use the symmetry. And I left off the squared. Thank you. And again, this would be a chuck that into your calculator kind of a thing.
Hey, I forgot the square. No. Without the square, it's 1.
Without the squared, it's 1?
With the square, it's 1.2146.
1.2146?
Yep.
Now let's think about the reasonableness of that. So I've got half of a circle with a radius of 1. So that's pi over 2 minus a little. Pi over 2 is,
1.57.
yeah, so, okay,
Fair enough.
that seems reasonable.
Yeah.
Doesn't necessarily mean that it's right, but at least it means it's in the ballpark. Okay?
Okay.
Any other questions?
No. Okay.
Okay.